Greetings. Welcome to Electrovaya's Battery Technology and Investor Day conference call and webcast. At this time, all participants are in listen-only mode. A question and answer session will follow the formal presentation. We will be taking questions today from the phone lines and the webcast. If you have dialed in, please press star 1 on your telephone keypad to join the Q&A queue. If you have joined via the webcast, please use the Ask Question button on your webcast viewer window. Shareholders and potential shareholders should submit their questions via the webcast today. If anyone should require operator assistance during the conference, please press star 0 on your telephone keypad. Please note this conference is being recorded. I will now turn the conference over to your host, Dr. Raj Dasgupta, CEO at Electrovaya. You may begin.
Thanks, everyone, for joining our second annual Battery Technology and Investor Day. This is going to be a very fun discussion talking about our new technologies, our existing technologies, and some new announcements that we plan to make today. We'll start with the disclaimer. So, of course, we're a publicly listed company both on NASDAQ and the Toronto Stock Exchange. And today we will be, in today's presentation and discussion, forward-looking statements will be made. So please take that as read. So for those who don't know us, Electrovaya has been a major battery player for the last 20 years. We currently are built around a technology which we call the Infinity battery technology. Now, this is a battery technology based around a whole bunch of technologies, including full ceramic separators, unique cell design, electrolytes, etc. And the outcome is much better safety and much better cycle life. We've deployed this technology in over 28,000 battery systems, whether those be in electric vehicles, or material handling vehicles or robotic applications. And interestingly enough, not a single one of those systems featuring this Infinity technology has had any battery failures. No fires, no safety issues whatsoever. Currently, our major focus on Infinity batteries has been in the material handling space, where we currently supply over 14 Fortune 100 companies for their warehousing applications, and over 200 warehouse sites currently. The company at our team at Electrovaya is very fond of tech, has a very strong tech focus. We have over 45 engineers and scientists. About half of our staff are in that category. And we have a major focus on technology, and that's demonstrated with our IP portfolio, which continues to grow. Jason, next slide. So in today's presentation, I'll be talking about both our two technology platforms, the Infinity battery platform, which is commercial today, and which we continue to make great strides in improving. And the second is our solid-state battery platform, which I'll discuss later in today's presentation. The Infinity battery technology and the solid-state battery technology both are based on, have significant inputs from ceramic-based separator technologies, which we have developed, and our expertise around making lithium-ion battery products with these types of materials. The Infinity battery technology we formally launched really in 2018 and have seen significant growth in the heavy-duty sector. And heavy-duty sectors are applications using batteries for much higher levels than you typically see in your electric vehicles. So your material handling vehicles inside warehouses may operate 24 hours a day, while your typical passenger EVs will operate for maybe 1 to 2 hours per day. So the need for higher safety, better cycle life is key in these types of applications. Just looking at our overall technology portfolio as of today, we have extensive IP and know-how around ceramic separators. What is a battery separator? A lot of you may ask. The separator is the material that goes in between your plus and your minus electrodes, or cathode and anode electrodes, in a lithium-ion battery. And its purpose is to keep those two electrodes apart and allow lithium ions to pass through. It's a key, it's the most important material in the battery for safety. And in our case, our separators are over 90% by weight ceramic, much higher than typical lithium-ion batteries. Your phones, for instance, may not even have any ceramic content. And that ceramic enables much higher thermal stability, much better safety in our battery products. We have over 30 patents in the area of ceramic separators, and even more importantly, significant know-how in the use of them, the production of them, and how to optimize cells with these materials. On the chemistry standpoint, our initial Infinity products have been based on NMC chemistry, so on the cathode side, and graphite on the anode side. Fairly typical chemistries used in the electric vehicle space. The major difference between ours and those is on the safety front. We're much, I would say, much far superior. And then on the cycle life front, we have seen our cycle life to be around 10,000 cycles, while typical NMC cells are around 2,000 cycles. So a great leap forward in the performance aspect there. Today, we also will announce our LFP version of the Infinity battery technology. This will be our first Infinity battery cells to use LFP chemistry. Again, we expect the same benefits to be shown in this chemistry. So improved cycle life and improved safety. LFP has some advantages in terms of cost, which makes it an attractive chemistry for certain applications like energy storage. And it's something that we plan to develop, and I'll come to that more detail later in today's discussion. And then, of course, a lot of our team here is working on battery systems and battery packs. So the number one, and I would say our Infinity series products have two key competitive advantages. And the first one is with regards to longevity. So this is the number of charge-discharge cycles you can do on a battery before it reaches its end of life. Of course, most of you are familiar with your cell phones, which after about 2 years you'll see a noticeable decline in the battery life and the battery performance. And that equates to about 1,000 cycles on a cell phone battery. So 1 cycle a day, 2.5 years, about 1,000 cycles. EVs, they use slightly better cells for those, but maybe you're looking at 2,000 cycles. And in Electrovaya's case, that's over 10,000 cycles. So if you were to put our battery in a car, you would see over 3 million miles on that car before the battery reaches end of life. Next slide. So obviously you don't need 3 million miles on your electric car, but your forklifts, your robots, your mining vehicles, which are operating 23 hours, 24 hours a day, do need that kind of cycle life. And that's what we're focused on. The graph there, third-party data from a lab in New York, where they benchmarked our cells versus competing cells from major players. We were miles ahead on the cycle life number. And no matter what the voltage range was, no matter what the temperature range was. Next slide. The other key benefit of the Infinity technology, and this is across the board, across chemistries, is with regards to the safety side. And the safety element, we believe, is something that this industry is going to need to pay more attention to as high-profile safety issues appear. And they reach the news on a regular basis, and we believe this benefit we offer ultimately makes the technology more attractive on a cost basis. Your insurance costs drop, your systems become more reliable, and your sales will improve on the systems that utilize a higher safety lithium-ion battery product. Next slide. So we focus a great deal on safety. For instance, we were the first battery player to have UL 2580 certification for our battery systems. And that's an automotive standard, which very few battery companies have been able to achieve. We expect to be the first battery company to achieve UL 2580 certification on a high voltage battery product, which is currently underway through that certification process. We've had countless third-party labs do validation testing and safety testing. And then finally, on the quality side, we proudly are ISO certified, but also following the Toyota production system. Going back to the separators, this is a key reason why our cells are so much safer. So in a lithium-ion battery, there are various reasons why a battery can fail, right? And fail meaning getting too hot. It can be external, it can be damaged from an accident, it can be something internal as well. But all these factors lead to a cell getting too hot and leading to a separator that shrinks. And when the separator shrinks, you obviously get a much larger problem, which leads to a fire, and that cascades with whether that's inside the cell or from this cell to a neighboring cell to a neighboring cell. In Electrovaya's case, that's where the ceramic material really shows its benefits. It is stable at high temperature, making even if you instigate a failure in the cell, it makes it highly unlikely for that to catch fire, and even less likely for a neighboring unit to catch fire. Next slide. We've done countless safety tests on our cells, including nail penetration, projectile testing, where they fire, I don't know what they fire projectiles at the cell. Most cells will catch fire under these conditions. Electrovaya's have not. So extremely safe battery technology. Next slide. And very recently, just a few weeks ago, we did a test internally where we took a high voltage battery system of 75 kilowatt hours in capacity. That's a relatively large battery pack. And we forced a cell in that pack to go into thermal runaway by heating it up. And we had to heat that cell up to over 300 degrees Celsius. There's no cell in the world where you have to go up to 300 degrees Celsius to make it catch fire. And when we finally did get the cell to catch fire, it did not propagate to the neighboring units. And just a little puff of smoke came out of this battery pack. Very, very safe technology. This is an outstanding result, which you would not see from any other supplier, in my opinion. So go to the next slide. So where do we see the future of this Infinity technology? I think this is the only technology that has been designed from the ground up to be optimized for heavy-duty applications where cycle life matters, and also heavy-duty applications where safety matters. And when you're building large electric vehicles, the battery sizes can be in the order of 500 kilowatt hours per vehicle. These are systems where safety is going to be critical, and of course cycle life is going to be critical. And there, if you look in the news and see what heavy-duty vehicles have used thus far, they've used automotive passenger vehicle batteries with, I would say, mixed results. There have been countless recalls, countless safety issues, and on the performance side, I don't believe those battery technologies will stand up to the time factor where they may need to be replaced early. So I think Electrovaya's technology extremely well positioned to succeed in these markets. And these are, we're not focused on the passenger EV market. There are various factors. Number one is on the margins. We would not be able to sustain the margins that we currently do in that market. That market is extremely cost competitive. Also, that market, they don't need batteries that have the cycle life that we do, and they're more focused, again, on that cost per kilowatt hour factor. So Electrovaya's strategy is on the Infinity technology to focus on applications where the cycle life really has a benefit and the safety really has a benefit, and where the end customer is prepared to pay for that benefit. And that's what we've succeeded in doing in the material handling space, where the bulk of our revenue currently comes from. We're seeing about 35% gross margins. We're expecting that to continue to improve. And every sector that we're targeting, we expect to get strong margins. Our batteries are currently deployed in a fairly wide variety of applications, from, of course, material handling vehicles. We're starting to see development in larger material handling vehicles with our OEM partner. AGVs and robots are definitely a growing sector for us. We also see our systems gaining traction in the defense sector. I believe that's due to the safety and performance aspects of the technology. Next slide. And we're getting into new sectors. So what's next? Mining. We're expecting to start our first electrification project at a mining site soon. We're also launching products for some heavy-duty aspects in ground equipment at airports. And then finally, on construction vehicles, where we have an OEM in Japan who will be using our batteries for their vehicles, which will be used across the world. Now I'd like to touch on the LFP chemistry launch. So this is a product which we've had in development for some time, and we're launching today. This LFP has some various advantages over our NMC product and compromises as well. So the key advantage here is on the cost side. The cost per kilowatt hour of our LFP product we expect to be fairly significant drop over our NMC-based products. We also expect the cycle life number to even increase further from where we have it on our NMC products. And we've had cells in testing for several months already that are indicating this type of performance. We see the future of our LFP products on an application front on the stationary energy storage market, where we intend to launch products next year, and also perhaps on some lower cost material handling applications. The LFP chemistry has some advantages with respect to critical materials, which are more abundant and thus will remain less volatile and will probably remain cheaper in the long run. So Electrovaya's Infinity technology is a platform technology. It can be applied to any chemistry and get the same benefits. And by launching the LFP technology chemistry, we are broadening our capabilities. The cell will be the same form factor as our current NMC-based products, which are, and the LFP product actually has pretty good energy density and gives a 44 amp hour capacity in the same footprint, which is not too different from our previous generation NMC products. Good energy density, good cost, and very good, high performance. We're also well underway with the UL recognition process and expect that to be completed over the next few months. With regards to safety, again, outstanding safety performance, nail penetration, projectile tests, heating tests, every UL test that's passed. The LFP product is going to be used in our upcoming energy storage products, which will be launched in early 2025. And we see some alignment in interests with our material handling products. So our material handling battery products are going into major warehouses across North America especially. And these sites are seeing a need for increased energy resilience and improved peak shaving costs. And we expect to see our energy storage products enter the market with some of these existing customers we have. And it's sort of a good product to launch as an ancillary. Even in some of these mining applications I mentioned earlier, energy storage is going to be a key component. Our Jamestown plant is making great progress and we've recently received our permits to start production there. We have an extremely attractive energy cost at the site, and we're making good progress with regards to the project financing to begin procuring the major equipment for the site. Next slide. And one of the goals with our Jamestown operations is to localize and strengthen our supply chain. The cells that we will produce at Jamestown will have very little reliance on Chinese imports, which is going to be important for some of our customers, and also gives Electrovaya that security of supply over the long term, where we, of course, continue to leverage our Asian supply chain as well, but Jamestown really gives us dual sourcing capability. And now I'd like to touch on our solid-state battery efforts, which we have been relatively quiet about, and today we'll make some key updates for all of you. So the solid-state batteries are based off ceramic separator technology, which we're developing in-house, and of course leverages a lot of the know-how and expertise that we have developed with our Infinity battery technologies. Next slide. Now, just stepping back, I'm sure most of you know this already, but why do we want to develop a solid-state battery? The answer is its energy density becomes very attractive. You're essentially eliminating your anode material in the lithium-ion battery, which takes a lot of space. You're also eliminating a fair bit of your electrolyte weight, and your separator is acting as your electrolyte. So you're enhancing the energy density of the lithium-ion battery by almost a factor of 2, which makes it extremely attractive for certain applications. For instance, if you have a high-performance electric car, your battery weight can drop by half, or your range on that vehicle can double. Your consumer electronics can get more powerful. So this is a technology that not just Electrovaya is trying to develop, but a lot of major battery companies and startups. Now, why do we think we can be successful here? Well, we do have unparalleled experience with regards to ceramic separators. All major solid-state battery efforts are built around ceramic separators because that ceramic material in a solid-state battery has to be the ion carrier. It has to act as the electrolyte as well as a separator. So the ceramics become incredibly important. Next slide. And so at our Electrovaya Labs division, we've started developing our own proprietary ceramic material. And the team there has been working diligently over the last 18 months on this ceramic material. And we went after this with a long-term perspective. So we didn't just want a high-performance ceramic material, which is too costly to be commercialized. We didn't want a high-performance ceramic material which you can't produce in scale. So that's what we went after. We ensured the materials were not too rare, that could be procured domestically, and could be scaled up in production. Next slide. And the other, of course, outcome is to have high performance. And today we are seeing very good performance on our ceramic materials. These are getting higher ionic conductivity than we're seeing in published from our competitors and in published research. So we also are expecting to see further improvement in this ionic conductivity. Now, why is ionic conductivity important in a ceramic separator? Well, this is the higher the ionic conductivity of that material, the faster you can charge the batteries, the faster you can discharge the batteries, the more viable it makes it across temperature windows. It is the most important metric in a solid-state battery. You're replacing liquid electrolytes, which are, of course, have high conductivity with this type of material, and it has to perform well. And we're pleased to see very good results from these materials. Then the next step is taking that ceramic material and making a separator out of it. And initially, we started producing relatively small material separators for small, I would call them button or point cells, and we've since progressed to making sort of sheet-sized ceramic separator membranes. And these are being used in our prototype pouch cells, like the one that is shown there. The overall design is to use that ceramic separator in between the cathode and where the lithium gets deposited, which would be the anode. And we eliminate the graphite electrode. We eliminate most of the liquids there, and the end result is a very high energy density cell. Next slide. So this is relatively early still, but we're seeing stable cycling results with this new approach to our solid-state battery design, and we're very excited with the performance we're seeing. Again, the target for solid-state batteries is just to isn't the same as our infinity battery technology. Infinity batteries have to go for that 10,000 cycles and be used in 24/7 applications. This solid-state battery, the target market, is entirely different. If we can demonstrate even 300 cycles, this is a viable technology to be commercialized at scale. So where are we on our roadmap? Well, in 23, we spent most of that year on efforts in developing our ceramic material and the processing to make that material. And this year we've started prototyping those cells with our new separator. We're in discussions with a high-performance automaker who has agreed to take. We're working out to send samples to them later this year. And there are other efforts with regards to making the cells larger, making the separators larger, and increasing the capacity. Overall, I'm very pleased with the progress, and Electrovaya is going to continue making efforts in our solid-state battery development. So that's that for the main part of the technology aspects we wanted to talk about. But just overall, as a business, Electrovaya is a technology company. We are selling our products based on that technology differentiation and that technology benefit that we offer. And because of that, we're able to get probably the highest gross margins in the battery space today. Last quarter, we had 35% margins on our battery products. We expect that to remain at that level and increase over the coming quarters. And our focus is on the bottom line. And we want to remain, we've had about $5.8 million in trailing positive EBITDA. That number we expect to further improve. We're seeing in 2024, as we mentioned in our last update, we've seen some sales move from 24 to 25, but despite that, our profitability is going to be extremely strong. And in 2025, we expect to see both significantly improved revenue and significantly improved profitability. And that trend is demonstrated through our recent financial results. But Electrovaya is in this business for the long term. We're going to be seeing these additional verticals take hold for our Infinity technology. And then, of course, the solid-state battery technology, which has a longer time horizon to commercialize, but is demonstrating very interesting results right now. And with that, we'll take questions.
Yeah, well, that will, conclude the formal presentation given today. And as we do have the pleasure of having in-house guests for today's event, we'll open up for some questions if anyone would be interested.
Samir Joshi from HC Wainwright. So for the LFP product, are you using the same ceramic material and with tweaks maybe? And does it retain the high power characteristics?
Exactly. So it uses the exact same ceramic separator that we use in our NMC-based products. We also see, in fact, the power capabilities of the LFP product are higher than the NMC product.
Yeah, that's correct. So yeah, normally, as you know, like LFP batteries has like higher electrical or lower electrical conductivity, but due to some changes and some improvement that has been done over the last couple of years, from not only from us, our side, but also some other manufacturer to improve the conductivity, like, you know, by carbon coating, by some like making some nanostructures. This has been already like reduced to a great extent. So the result is that our LFP has, as what Raj mentioned, has higher rate performance, especially like above like certain SOC range. So we can get to as high as 9C with 60-second pulse discharge. Yep.
And then on the same topic, on the cycles front, does the use of this ceramic affect the cycles in a positive way or negative way?
In a positive way.
Okay.
So we're expecting, you know, in the NMC-based product, it's taken years to get the cycle life numbers that we've seen, right? That we're doing a couple cycles a day every day at our labs and at third-party labs. And at the third-party lab, they've just crossed, 4 years of testing? We're crossing that 9,000, 10,000
right now
cycles.
It's almost 13,000.
13,000 cycles. The LFP product, because it's just being launched, it hasn't got that 4 years of data behind it yet, but we're expecting to see results which are even better than the NMC products because of the LFP chemistries generally sees better cycle life than NMC. Eric?
Hi, Eric Stein from Craig-Hallum. So on the margin front, just curious in material handling where things stand in terms of OEMs coming out with a purpose-built forklift for a lithium-ion battery. And what I'm thinking about is the potential margin improvement when you don't have to deal with the counterbalance weight and all of the, I guess it's kind of dead material in the product.
So what we're seeing, and some of this is, one of our OEM partners only makes electric forklifts, and our other OEM partner mostly makes internal combustion powered vehicles. And what we're seeing is the internal combustion powered vehicles are under pressure to be electrified, not just due to efforts to decarbonize, but also legislation. Like in the state of California, industrial vehicles have to be zero emission by 2026, which is just around the corner. So we're working with these partners to electrify some of those platforms, and those will be batteries that are designed into new vehicles. So you would expect to see, so counterweight would be removed, et cetera. In terms of the margins, though, I would expect us to retain the similar margins on products. However, I would expect our margins to improve further in general. And that's because we're seeing some of the costs of the input materials come down. Electrovaya has also improved our manufacturing process internally for higher efficiency, higher output per employee. We're seeing the scale having an effect on our buying power. So all these factors are working towards providing further improvements to the market.
And that's before you start thinking about the benefit from manufacturing your own cells, your own modules, the 45X tax credit, all of that, right?
Yeah, that's before the 45X tax credit. So we're expecting that to come in as well, and that'll have a further impact. So overall, that's the benefit of having the product based on its performance as opposed to just being a battery.
And the timing of expected module and cell production at Jamestown still?
We're still on track. We expect the demand side to really pick up, first of all, in 2025, but even more so 2026 onwards. And our objective is to have the Jamestown plant supplying the cells, the majority of our cells from 2026 onwards. And we're making progress in our setup at the plant. Also on the financing front, we're seeing good momentum building up there. Of course, this is with a government lender. Things with government take longer. However, they do a substantial amount of due diligence and validation, which we think is very valuable. So in our opinion, while we've had other offers potentially to provide funding to get Jamestown operating earlier, our preference is to work with this group. And I was in Washington last week giving a talk, and we have a good feeling this is going to get done. Put it that way.
just on the follow-up on this one, do you expect any challenges from a potential change in administration? And is it likely that you will want to get this financing done before election?
So we're apolitical, and the good news about Electrovaya's products is they're being bought by companies that are not receiving subsidies to use them. So in the warehousing space, those buyers don't get any incentive to go lithium-ion or Electrovaya's lithium-ion over any other type of technology. They are specifically picking our technology because of the performance and safety that we offer. And they are going electric for the same reasons, right? In warehousing, that's really gone full electric due to the better performance it offers over other technologies. So, and also going forward, we're targeting markets which are not dependent on subsidies. One market that we do see that has a strong relationship with subsidies is the bus sector, transit bus, school bus, and we're sort of shying away from that a little bit with a greater emphasis on applications which are independent of administration, subsidies, etc. So if there's a change in administration, we don't expect any change in our business. The electrification drive overall is a make sense technology change. It's irrelevant on the politics of it. We also see the production tax credit in Jamestown, for instance, likely not to be affected by an administration change.
Ask a question. Mike Kelly, Seaport Global. Curious in the solid state, if you do have success in the automotive sector, like, can you frame this in terms of the types of improvements and performance you'd expect to see? Just think about kind of your standard battery now, I don't know, 300-400 miles of range and time to charge. Maybe can you just give us a sense of what it could look like if you have success?
So the big benefit is it gives the OEM or the automaker huge flexibility. They can suddenly make a car that goes 1,000 miles if they want. Or they can make a car, you know, electric cars weigh more than internal combustion cars. And that's for performance cars, that's one of the detractions. So suddenly you can make that electric car, which out-accelerates internal combustion already, but then you can make the car lighter than the internal combustion car as well. So there's a huge variety of things you can do with solid-state batteries, which makes a very compelling technology for, I would say, especially the high-performance segment of that market.
Got it. So, I mean, it seems like it's completely game-changing for that industry if it's successful.
It would be. And not to say conventional lithium-ion batteries are being deployed in greater numbers and also are successful, but the solid-state batteries would remake that space.
Great. Just one more from me. You threw some good numbers going out to like 2027 there, both revenue and EBITDA. Just curious how the assumptions, just at a ballpark level, high level of contribution from various businesses, and if there is any solid state that's even built into the 27 estimates yet.
We haven't built any solid-state battery revenue in there. However, we expect to see, currently 99% of our revenue is material handling. Yeah. That while that space is going to continue to grow for us, we are expecting the weighting of that to drop below 50% by 2027.
Thank you.
Are there any other questions in-house? No, I'll pass it over to the moderator. Paul?
Thank you. At this time, we'll be conducting a question and answer session. If you have dialed in, please press star one on your telephone keypad if you wish to ask a question. A confirmation tone will indicate your line is in the question queue. You may press star two if you would like to remove your question from the queue. If you have joined via the webcast, please use the Ask Question button on your webcast viewer window. Once again, shareholders and potential shareholders should submit their questions via the webcast today by pressing the Ask Question button on their webcast viewer window, typing in their question, and hitting the Submit button. Please hold while we poll for questions. Once again, that is star one if you have joined via the dial-in to enter the Q&A queue. And there were currently no questions from the lines. I will now hand the call back to Jason Roy for webcast questions.
Thank you, Paul. So we do have a question coming in from Jeffrey Campbell from Seaport Research Partners. He may have missed this, but wanted a little bit more insight on the advantages and or disadvantages between the NMC and LFP Infinity batteries.
I would say the NMC, the advantage there is on the energy density. So the amount of energy you have in the unit volume or unit weight is going to be higher than the LFP-based products. So for applications which are very performance-driven, especially their vehicles, they're going to remain using our NMC battery technology because ultimately that provides extremely good performance, extremely good safety.
Addressable market increases.
Yeah. The LFP really provides us capability of getting to more of the stationary battery market, which with our NMC-based chemistry was too expensive for that space. And the LFP really, as Shankar mentioned, it widens that addressable market. Its core advantage is really in being lower cost.
Very good. Fielding another question from Herald Investments in the UK. In respects to solid-state battery technology, what would the markets, the solid-state, would it address specifically?
So again, I'd say automotive has a strong push to go solid state for the reasons I outlined with regards to performance, capability of having that flexibility in increasing range or decreasing weight. So automotive is a key segment that we would be targeting. And then like consumer electronics will be another space. Drones, electric aircrafts as well.
Aerospace applications.
So it's quite a wide variety of applications. One thing to note is there's no overlap with the applications that we're looking at with our Infinity technology, which is purely focused on a heavy-duty industrial application.
Now, I'll follow on to that original question. What would be the time horizons for potential pre-commercialization and commercialization for solid-state batteries?
Well, we'll be shipping cells this year. But they're pre-commercial. I would say this is still, with development, having a firm timeline is always difficult. But I would say commercializability definitely by 2027 is a feasible figure.
Just feeling some. I think that concludes the question periods coming in from the webinar currently.
All right.
I have a question here, if you don't mind.
Yeah.
So you described that test that you did in-house where you increase the temperature of 300 degrees centigrade. Is that a standard test, and are you looking to do like third-party validation, someone else doing that test for you?
So it is a standard test as part of the UL 2580 certification.
Okay.
We've done it in-house, and it is being done as a third party as well. the difference is most battery players wouldn't have to heat their products up to 300 degrees Celsius to make them catch fire. And also, we don't expect most players to even pass that test.
Okay, I think this concludes the question and answer period. Would like to thank all participants here in person today, and as well those who joined us via the webcast and as well as conference call. Wish everybody a great day, and we look forward to speaking with you again in our upcoming quarter conference call, financial results, and looking forward to future developments, and thank you for your time today.
Thank you. This does conclude today's conference call and webcast. You may disconnect at this time and have a wonderful day. Thank you for your participation.